Good morning, and welcome to today's session. It is an absolute pleasure to be here with you today. My name is Habib Heydarian, and I'm a program manager on the .NET team. There is my email address. If you have any questions, if you like any additional information about today's information, please don't hesitate to email me. There's a lot more information at the end of these slides, but I'm more than happy to answer any questions in the email as well. Today, I'm going to provide an overview of .NET 2015, and trust me when I say this, .NET 2015 is by far the largest release of .NET in terms of capabilities and new features that we've done since .NET was first released back in early 2000. So with that, let's get started. This is a good backdrop in terms of what our customers, and that obviously includes everyone in this room, is going through right now. We are hearing from a lot of customers, whether they're large enterprises or small ISVs, that they're facing a number of business challenges right now. And some of the most prominent challenges that folks are facing is they're being asked to deliver software on a much faster cadence. I can tell you, on our team, about 3 years ago, we used to have essentially 6-month milestones. Now we have 3-week sprints. And I'm sure a lot of folks in the room are going through the same transition as well. The other thing that we're seeing a lot of is a cross-device strategy. Customers are being asked, including ourselves, to deliver software and capabilities on not just a single ecosystem, but also across a variety of ecosystems, including Android and iOS. Open source is fast becoming a core part of a lot of people's strategies. I can tell you at Microsoft, we consume a lot of open source software now. In fact, you'll see starting a lot as well. And last but not least, with all the new challenges, customers are still facing the same challenge where they have all this existing asset and they need to be able to move it into a new world where open source, cross-device, as well as other requirements are piling on over time. So what does that mean? We took all these requirements in and we basically came up with a 3-pillar strategy. We spent a lot of time in this version of .NET focusing on innovation, and you'll see a lot of new capabilities in .NET 4.6, which is the next version of .NET Framework. Also a new offering in .NET Core that allows you to also target additional platforms. We've also not only embraced open source, but we are contributing to open source in a big way. In fact, if you look at all of our new work that's happening in .NET Core, it is all happening live on GitHub. And last but not least, we are making a big push into cross-platform. Specifically, we are making a lot of investments to enable customers to run their server/cloud scenarios on Linux as well as OS X. And you'll see a lot more of that going forward. Let's start with innovation. This is a very high-level overview of what .NET 2015 is all about. On your left-hand side, what you're seeing is the next release of .NET Framework, which we are calling .NET Framework 4.6. You'll see in the upcoming slides that we're making a ton of investments, whether if it's new language features, WPF investments, or core investments in the runtime and our JIT compiler. And then on the right-hand side is a new offering that we're calling .NET Core. .NET Core is the foundation that allows us to enable brand new workloads that we currently are unable to address, including the ability to run .NET on Linux and OS X. And also we have a brand new technology called .NET Native that basically takes your IL and then compiles it down to native code using the C++ compiler. So there's no more jitting. And you'll see a lot more of that going forward as well. And both of these products share the same fundamental capabilities. Be it the runtime components, including the new 64-bit that we've designed, the shared libraries that we are releasing by NuGet, or the compiler features, including C# 6, VB14, as well as a new capability that we're calling code analyzers. And I'll get into more detail soon. OK, let's start with .NET 4.6. So starting with .NET 4.5, we made a change in strategy where prior to .NET 4.5, every release of .NET was pretty much what we call side-by-side. Starting .NET 4.5, one of the things that we took on was to provide this very highly compatible framework that allows our customers to upgrade their application in place without having to install multiple versions of .NET side by side. And what this allows us to do is it allows us to basically address scenarios where a customer can have a single version of .NET on a device, for example, that has a very small footprint as far as disk size is concerned. Because if we were to place multiple versions of framework on a device that has, for example, 16 or 32 gig of disk space, we will soon run out of space very, very quickly. So the latest version, .NET 4.6, again, we have taken on the burden of compatibility. And what you'll see is if you have an existing .NET 4 application, 4.5, 4.5.1, 4.5.2, it will just work on .NET 4.6. And so this is what our journey has led us so far. We started with .NET 1 back in somewhere around 2001, 2002. And then we introduced .NET 1.1 and then .NET 4.2. And then what we're seeing right now is essentially the latest pedigree of .NET, which is along the .NET 4.5 all the way to 4.6. And so that's where we are today. And what you see us doing is we'll continue to innovate in .NET going forward, but we're also going to introduce new capabilities such as .NET Core that allows us to take advantage of new workloads. So let's actually start by focusing on the most important aspect, which is developer productivity. We have made a ton of investments, and you'll only see the tip of the iceberg this morning, and we have a lot more sessions throughout the rest of the week where you're going to see a lot more detail on this. But we've focused on a lot of new language features in C# 6 as well as VB14. We've introduced a number of IDE improvements, including colorized tooltips where you basically hover over your condensed code and you'll see a colorized version of your code. Refactorings, as well as a number of innovations, including a new light bulb that you'll see in later sessions this week. Debugging is an area where we've invested a lot of time in, and I'll show you a brief demo right in a minute where we have heard over and over again where we have innovated in language features, but we've really left the edit and continue scenarios behind, including Lambda expressions as well as link statements. And code analyzers, it's a brand new code analysis framework. So those of you in the crowd have probably today used FXCOP or StyleCOP or any of the other variants. In .NET 2015, we have introduced a brand new code analyzer framework that allows you to address both style issues in your code as well as programming errors that might creep up as you're coding your application. So let's actually now switch to a demo and take a look at what we've done as far as edit and continue is concerned. So what I have here is our beloved Visual Studio 2013. It's a very simple program. It has a couple of methods. The first method basically prints out all the numbers in a list that are less than 5. And then the second method, it counts the number of odd numbers in a list. I'm going to start the debugger and hit the breakpoint. And I'm going to step into the method and step over. And while I'm here, it would be really nice if I can do things like, you know what, I'm just going to actually change that to high nums and change that through my program. And then let's change that to greater than. And I'm going to continue editing. And Visual Studio says, nice try, but no soup for you. And this is highly, highly frustrating. Imagine you've debugged your code. You're now at a point where you're like, if you could just tweak your code and to actually experiment with your application or figure out whether you actually found the bug or not, now you have to stop your application or back out your changes, which is very, very frustrating. So I'm going to edit the code, and I'm going to back out my changes. And once I've done that, I'm going to step out of the method. Now, let's continue on. I'm going to step into the show2 method. And here, what I want to do is, it would be really nice if I could do things like take this expression right here, which is a Lambda expression, and simply just put it in my watch window. And again, Visual Studio says, that was a nice try, but no soup for you. We cannot evaluate Lambda expressions in the variables windows. Now, let's switch over to Visual Studio 2015 RC and see what that looks like. Here I have the exact same application, and I'm going to start the debugger and step into the code and step again. And what I can do is simply change that to high nums. And then change that to greater than and continue. So as you can see, Visual Studio 2015 allows you to edit and continue link statements. But also, the other thing that I can do is, let me step out, step into show2, and I can basically take this entire expression, put it into my watch window, and evaluate it. Just do it again. Evaluate it in the watch window as well. But I can even do, thank you. But I can do even more cool stuff. I can take this entire statement, go to my immediate window, paste it in, change that to even numbers, and then basically do things like that. So what you can see in the Visual Studio 2015 debugger, thank you, I should stop, I guess, is you have an incredible amount of flexibility of what you can do with the debugger. So that was just a very small fraction of the new debugger features that were introduced in 2015. In fact, we've also introduced a new syntax for object IDs, and we have a session later this week that shows you how you can use object IDs to do things like per object breakpoints in the debugger. That comes in really handy if you're iterating through a loop or debugging multi-threaded applications. Okay. Next, this is one of my favorite questions, quiz. What's the most requested feature that people want from WPF? Anyone? Debugging XAML? Good guess. A roadmap. Let me share with you why. And I'll be perfectly candid with you. We've done an absolutely terrible job, and I mean terrible, in the last few years, sharing with our customers what is going on with WPF. In fact, if you look at our blogs, our presentations, whichever media outlet you look at, we just did not communicate well what's happening with WPF. So the first thing that we've done now is we now have a full roadmap for what we are investing in WPF going forward. That is available on our blog. You'll see a link at the end of this presentation where you can, at your leisure, sit down and figure out exactly what we're doing as far as WPF is concerned going forward. But let me share with you 4 high-level areas of investment that we are making in WPF going forward. The first one is performance, performance, performance. We are making a number of improvements in WPF to make your WPF application more performant. The other one is, as there are new innovations around DirectX 11 or 12, we want to be able to take advantage of those features in WPF so that as new hardware comes out, for example, the WPF apps can actually take advantage of that new hardware. In fact, if I remember correctly, the current version of WPF is still based on DX903, which was released sometime in 2004. So it's about time to actually make that happen. Supporting modern hardware. I mean, devices are pretty much everywhere. Touch is ubiquitous. And what we are doing with WPF is make touch a lot more of a first-class citizen. And also things around high DPI and high-resolution monitors. We're making investments to make that a lot better experience for customers. And last but not least, we're making a ton of investments in tooling. Whether if it's a XAML debugger or a performance diagnostics tool, we're making a bunch of investments in .NET 4.6. So let's start with some of the investments that we are making in the runtime. What we are doing, as I mentioned, we are investing a lot in the touch experience. Specifically, what we're hearing from a lot of customers is there's this lag time, or touch is not accurate when I actually use my WPF application on a touch-enabled device. So that's one of the areas that we're really investing in to make touch a first-class citizen as far as WPF applications are concerned. The other one is around when the UI thread is busy, making touch a lot more responsive. Today, I'm sure some of you have experienced where if the UI thread is busy right now, the rest of the application is somewhat sluggish, and that actually really impacts the experience as far as the end user is concerned. Scrolling. WPF is the most common used UI framework for developing rich, intensive applications. And that includes being able to view lots and lots and lots of data, which includes lots and lots of scrolling. And what we hear a lot from customers is once you hit a certain threshold, the application becomes really sluggish, and you get complaints that scrolling the app becomes pretty much impossible. And so we're making a lot of investments in being able to traverse large amounts of data in a WPF in a very responsive manner. And then also high DPI improvements. One of our mantras going forward is, as the OS adds capabilities, or as the hardware becomes more capable in a variety of dimensions, we want to basically bring WPF forward along. So one of them is with high DPI screens, we want to make sure we don't suffer from things like clippings or things not being rendered correctly. And here an example is it's supposed to say VS MS build, and it's being cut off right now because the control is actually suffering from clipping. So these are the things that will basically, your application, if you're running your WPF application on 4.0, 4.5, 4.5.1, 4.5.2, by you just installing your application on .NET 4.6, these things will actually get better without you having to compile your app. Transparent child windows. So this is also a very often requested feature, especially in the gaming community and also in applications where there's requirements for displaying some financial data over existing information. So up in the right-hand side corner, you'll actually see the red circle being rendered, and you can see it's completely opaque to a point where it looks like a big blotch, so to speak. And on the lower right-hand side, you'll see that same red circle being rendered, and it's this beautiful transparent window, so you get a lot better experience. So if you have experiences where you have a heads-up display, for example, in a game, or you're displaying some information on top of each other, it becomes a lot more kind of nice, so to speak, to deliver those experiences without you having to put together massive amounts of hack. So that was on the runtime side on WPF. On the tooling side, we are making a huge amount of investment. As the gentleman mentioned here in the front row, one of the biggest pain points for WPF customers is understanding what is going on with my WPF app. It's when you think about it, you have both markup and your basically code and trying to reason about what event happened and what was the actual root cause of that event. Also understanding why is your application performing slowly. Those things are quite difficult to debug. We hear a lot of customers, for example, having to use tools like XAML Spy. That's a very frequently used tool to debug WPF applications. And so what we've done in VS 2015 is, in VS 2015 RC, we've added a number of diagnostic capabilities to make it a lot easier to figure out what's happening with your application. With that, let me show you a very quick demo. Again, this is Visual Studio 2015. And I'm going to bring up the demo solution. Let me just dismiss that right now. And if I were to just run this, it's a very, very simple WPF application that basically allows a project manager to track their time. And so once the application actually comes up, you'll see, it's a typical WPF app. We have a bunch of charts and controls, and you have a map on top. And so you have the time entry feature up there. Let's say that I actually wanted to now figure out which controls these arrows map to, and I also want to actually turn these circles right now that are grayish into red. How would I go about doing that? To do that in Visual Studio today is extremely hard because trying to map which control maps to which part of your code at runtime is quite difficult. So I'm going to dock this to the right-hand side of the screen. And, excuse me while I bring this up. So the first thing that you notice is we have a diagnostics tool right now that basically allows you to see exactly what is going on as far as what events are being fired and when. And the other thing that I want to highlight is the fact that as I interact with my application right now, you'll be able to see all the debugger events that are being fired. That is because we have now essentially instrumented parts of WPF to tell the debugger exactly what is happening. And what you'll be able to do is very similar to various diagnostics tools that you can download for WPF today, is figure out exactly what happened in your application. Let me now quickly switch. And traverse our 596 windows that we have to see if I can find the one that I'm actually looking for. Okay. Okay, I think I messed around with my layout a little bit, and for some reason the actual window is no longer showing. But so what the window is supposed to do is very similar to the XAML Spy. You can basically use it to figure out exactly which elements in your application map to which elements of your code as well as your markup. And if I get that working in a second, I'll switch back. But let me for a second switch back to my slides and continue on. Okay. So underneath all this, the thing that is powering .NET 2015 is at its core is a brand new compiler that we've codenamed Roslyn. For those of you who may be aware, Roslyn is the first incarnation of the C# compiler that itself is written in C#. Up until VS 2013, the C# compiler was written completely in C++. And so it actually made it quite difficult even for us to add brand new features, such as refactorings in the IDE or brand new code analyzers. So with VS 2015 and C#6, with Roslyn, you basically have a brand new compiler that compiles both your C# and VB code. The other thing that it allows you to do is you now go from this isolated closed compiler to this open source, open API framework that you can extend pretty much in every single dimension that you like. And using it, all the new refactorings that you're going to see in VS 2015 are completely powered by the new Roslyn framework. And the new code analyzers that will essentially, over time, phase out things like fxcop and stylecop are completely written in Roslyn as well. The thing that I do want to highlight is this. Today, for those of you who are brave enough to want to write a rule for fxcop, you probably have noticed that's a very daunting task, trying to understand exactly how to reverse engineer some of the IL code to be able to write a fxcop rule. With code analyzers and Roslyn going forward, it's going to be a cinch, essentially, to now write analyzers for your application. It's basically all C# code. And the commitment that we're making is, whether if it's our refactorings or our code analyzers, we are going to open source the entire set so that you can then base your analyzers and your refactoring based on the set of rules and refactorings that we have. So I mentioned that Roslyn, the new C# compiler, is essentially the compiler that powers the entirety of the .NET 2015 going forward. What does that actually mean? So what you see on the screen right now is what the workflow for .NET Core looks like. In .NET Framework 4.6 or earlier, there was pretty much a single compilation model where you took your C# code, you ran it through the C# compiler, and then that was JITed at runtime. Or you could have used the Ngen, which is the essentially the native compiler, to pre-compile your code, which unfortunately suffered from a number of problems, including brittleness. With Roslyn and also .NET Core, the main difference is that you basically take your code, run it through Roslyn, and then also, unlike the existing version of .NET Framework where you have a monolithic version of .NET installed on your machine, you basically have a modular set of libraries that are all NuGet libraries that are part of Visual Studio, and you can also update, that allows you to rev your application a lot quicker than what you can do today. And so you take that, and depending on whether you're writing your a universal Windows application or a ASP.NET 5 application, the code will either go through a brand new compiler that will run, calling .NET Native, that will produce literally native CPU-specific code. The backend for .NET Native is exactly the same backend as the C++ 14 optimizing compiler. So the code quality is tremendous, and we've seen some massive, massive improvements. And then if you're using a WPF, ASP.NET 5 application, you basically take the IL code and it gets JITed with our brand new JIT, which is a 64-bit JIT that we're codenaming RealJIT. So with that now, once you've actually then used the Roslyn compiler to produce your code, it becomes the core of building universal Windows platform applications. Specifically, all universal Windows platform applications are now based on .NET Core. If you were to build a store application today, it's still based on .NET Framework. 4.51 or 4.52. Going forward, all store applications will be based on .NET Core. And what that specifically means is your code will be compiled to native code without you having to make any changes or having to learn new syntax. Speaking of .NET Native, we are seeing some amazing results. If you're writing your store application and with Visual Studio 2015, this is the compiler that we are going to use to compile your application. It is the next generation compiler that actually compiles your code in the cloud. So if you've written Windows Phone application today, you'll notice that you upload your IL to the cloud and it gets compiled down in the cloud. With .NET Native, that also all happens in the cloud. And the other big key factor of .NET Native is the fact that the code execution is much faster, and also the memory footprint is a lot smaller. And so what we've seen is that we've been working with several developers, including Wordament, which is a very popular game on Windows Store and Windows Phone, and they have seen some tremendous improvements in both the cold startup, warm startup, as well as memory usage. The first question that I get about .NET Native is, that's fantastic. I want the same set of capabilities for my WPF app, also for my ASP.NET app, so that I can pre-compile my .NET app to native code so it doesn't have to JIT. The other key advantage of .NET Native is the fact that you no longer have to deploy .NET to the machine. What actually happens is with .NET Native, it takes your entire code, then it also compiles in the .NET libraries that it needs, and it creates a single binary. If you're aware of C++ semantics where you have static linking, it's the exactly same notion where it will statically link all the libraries that it needs into a single binary. So deploying an app now, it's simply a matter of X-copying your application into whatever machine that you need going forward. The question is, how is this different than Engine? The key difference between this and Engine is literally nothing but a memory dump of your native code. It's extremely brittle. In fact, every time we service any of our framework libraries, we have to rerun Engine. The really nice thing about .NET Native is it's exactly the same code that would have been produced by C++ code. So what you're running in this case is just a statically linked binary that is completely isolated from the rest of the system. If we were to ever update the machine, for example, your application would not be impacted in any shape or form. The question is, how does this actually reduce the memory footprint when you static link and actually brings in more libraries? We have a technology called a dependency reducer. We will shake out all the APIs that the application does not need and only use the APIs that it needs. So you're no longer having to pay the upfront cost for bringing in the entire framework when you bring up your .NET Native application. And that's the key difference that we're saying, is that we're using a dependency reducer to get rid of everything that the app doesn't need. Let me switch over and show you a very quick demo of what .NET Native actually looks like. So here I have a very simple store application. And I'm going to start it in the debugger. Excuse this dialog. We have a bug right now, but it's going to be fixed soon. So I've stopped so I can debug my code as I can do usually. This is literally native code running. And so I can look at my expressions in the various windows and so forth. Some of the things that you cannot do when you're using .NET Native is editing continue does not work. Just my code doesn't work because, again, you're literally running native C++ code. And in fact, going back to the gentleman's question of what's the difference between this and Engine, trying to debug an engine application is vastly different trying to debug this. So we have first-class support. In fact, we even have dump debugging support. So after you've basically created your PDBs, you can still load them, load your code in the debugger, point it to your PDBs, and still continue debug your application. Let me just go and reset the window layout so you can see what's going on. So in the debug menu, I'm going to show you the modules window. And the thing that you'll notice about the modules window is something very interesting. You'll notice that on the path now, you no longer see a path to anything because those modules have now been embedded within your exe. As I said, you have a single exe now where all the .NET libraries that were previously JITed and loaded within your process have now been pre-compiled. We've reduced and shaken out all the dependencies that it doesn't need, and we've only linked in the dependencies that it does need. So as I mentioned, the app model for .NET Native is very attractive. So for this version of .NET 2015, we're making it available for store applications. We are looking at what we'd like for console applications as well, and then try and figure out for additional app models such as WPF and WinForms, what would that look like? However, that's still a much longer road that we need to traverse going forward. But so far, the promises of .NET Native are pretty amazing when you think about the set of capabilities that it has. Yeah. The question is, with .NET Native, you no longer need the global assembly cache or GAC. The answer is absolutely no. You don't need it anymore. As I mentioned, deployment via .NET Native is a simple Xcopy. There is nothing to actually install on their own machine. So it becomes... Now, as I said, I do want to be completely frank here, is that for this version, we're only making it available for store applications. However, we are absolutely looking at how we make this technology available for the rest of the existing stack as well. But I am actually very happy with the road that we're taking with .NET Native. Okay. I mentioned early on in the slides that one of the most common questions that we're getting from our customers today is, I have my existing .NET assets, and they work great on my desktop application, but I've been asked by my CTO, CIO, or my customers to make those assets available on iOS and Android. So our answer there is that we have a great partnership with Xamarin. Xamarin basically does all the work to take your existing .NET application and run it on both iOS and Android using the Mono runtime. So they have an extension in Visual Studio, but also they have their IDE Mono developed that allows you to also build your .NET applications in that IDE. One of the really nice things about the partnership with Xamarin is the fact that what we've seen is customers can share pretty much up to 70–80% of their business logic and use things like portable class libraries. And then depending on which OS they want to deploy their application to, be it iOS or Android, then use the presentation framework that's applicable for that stack. So in this case for iOS, basically using C# plus XIB as the presentation layer, and then on Android using AXML. And then obviously for Windows, it's the native XAML stack that is available. In my opinion, this model is very nice in the sense that it allows customers to leverage a lot of their existing investments, and they don't have to rewrite their app or have to hire brand new talent in their companies to be able to target these additional platforms and operating systems. I'm sorry, I missed the question. The question is C# the only language that's supported here? And the answer is yes. So one of the nice things is, in conjunction with Xamarin, there is actually full support for not just writing code within the Visual Studio IDE, but there's also support for designing your application. So what you see on the top half of the screen is actually the iOS app designer that's available in Visual Studio, where you can design your application for all sorts of form factors, being an iPhone or an iPad or the various sizes of iPhone or iPad. It's the same semantics as you use with WinForms today or any other designer. It's simply drag and drop. And the other thing is the fact that it's saved in the native resource format. So as I said, whatever the actual presentation layer is that is used on that OS, that's the format that's actually generated. And then the other thing here is the fact that once you actually design something, the experience is very similar to Visual Studio, where you can basically go and debug the application and then go from there. So now imagine having your core business logic that you have a XAML head, an iOS head, and an Android head, where you basically share the same core business logic amongst all these different OSs. Yes. Correct. So the answer is when you're designing the actual UI itself, you're repeating the markup language for each specific OS, and the answer is yes. So as I said, for iOS, it's XIB, and then for Android, is AXML, basically. But the core business logic, you basically share amongst all the different projects. I'm sorry, would you mind saving your question towards the end of the presentation, where we have mics in the middle, and then I'll be more than happy. I had a hard time hearing you, and I don't want to misrepresent your question. Sorry about that. Okay, so so far we've focused a lot on the client side of the stack. We talked about WPF investments. We talked about the new investments that we're making for building store applications, including .NET Native. And then we talked about how you do cross-platform development on the client stack as well. Let's actually switch gears a little bit and talk about the server stack. I'm sure a lot of you in the audience are doing ASP.NET development today. So, in a nutshell, ASP.NET 5 is a brand new cloud-optimized stack for building ASP.NET applications. It was built from the ground up to essentially be completely modular, and it doesn't require kind of the entire framework to be able to run an ASP.NET 5 application. The other thing is the fact that editing, for example, and the whole edit, compile, debug cycle is much, much faster, because we now use an in-memory compilation model for building and debugging a ASP.NET 5 application. The reason why we could do this type of investment is the fact that if you look at .NET today, we have this amazing, consistent, but monolithic framework that you install on your device, you install on your desktop, you install on your server. One of the most common complaints that we get, for example, is for server/cloud scenarios, we make a hotfix in WPF or Windows Forms, and suddenly a customer who has a server workload has to essentially update their machine. And so we have customers who look at us funny saying, you just made a change in your presentation framework, and you asked me to make a change in my server stack. How is that reasonable? So with ASP.NET 5, we've now taken the approach of pay as you go, meaning you will only pay for the things that you actually use and no more. So it's an extremely modular model. And of course, just the rest, like the rest of the .NET Core stack, it is completely open source. So you can get the entire stack. The first question that I get once I actually talk about ASP.NET 5 is, so what is different between ASP.NET 5 and the version of ASP.NET 5 that runs on .NET 4.6? As I mentioned, if you remember the third or fourth slide where I showed both the .NET 4.6 stack and the .NET Core stack, ASP.NET 5 can run on both stacks. However, if you were to run your ASP.NET 5 on the .NET Core stack, there are a number of features / experiences that are only available when you run it in that mode. The first one is it's fully side-by-side. You can deploy your application by Xcopying a single directory that contains your app, as well as it contains the entire .NET Core framework, and that's all you need. There is no GAC util to install the framework. You don't have to do anything like that. The other thing is you can now have essentially 10 different directories with 10 different ASP.NET 5 applications, each with their own runtime and framework. So if you were to update the runtime and framework for one app, it doesn't break all the other applications, which is a very, very common complaint that we get from customers where we update the framework and suddenly all applications are on the floor. The other thing is, as I mentioned, because ASP.NET 5 and .NET Core were built from the ground up for device-specific and server-specific workloads, both the memory footprint as well as the startup time is a lot faster. One other thing that I do want to mention, and I'll discuss this towards the end of this presentation, is the other key benefit is if you want to run your ASP.NET 5 on OS X or on Linux, then you have to use ASP.NET 5 with .NET Core. Let me show you a very brief overview of what ASP.NET 5 looks like. We have 2 sessions towards the end of this week where we're going to do a lot deeper, both 300 and 400 level talks to describe the rest of the capabilities. So first of all, I'm going to new up a new ASP.NET web application. And the first thing that you notice once the dialog comes up is the fact that we now have 2 categories of templates. The first one is ASP.NET 4.6 templates, and the other one is the ASP.NET 5 templates. Right now, they're in preview or RC mode. So I'm going to select an empty website, and I'll click OK. Once I do that, it basically creates the scaffolding for my application. And the other thing that it does is, if you remember I mentioned ASP.NET 5 is completely modular. So rather than having these static references, for example, you'll notice that my references, there's this restoring parentheses right next to it. What it's actually doing is it's making sure that it has all the NuGet packages that it needs to run your application. And to do that, it basically looks up a central repository to make sure that all its dependencies are there. Once it's there, the first thing you notice is you now have 2 high-level nodes. You're probably wondering, what does DNX 4.5.1 and DNX 5.0 actually do or stand for? First of all, if you remember, I mentioned your ASP.NET 5 application can run on both .NET Framework 4.6, and it can also run on .NET Core. So we haven't updated the string right now, but that should say .NET 4.6. So if you want your application to run on .NET 4.6, those are the set of references that you have for your application that you need to make sure you have the dependencies for. And if you want to run on .NET Core, then you need to make sure that you have the right set of dependencies there. And you can go and configure which runtime you want to run your application on in the project properties. Okay, so the question is this. I mentioned that you can essentially run your ASP.NET 5 application on both .NET 4.6 and .NET Core. And how does it work with things like your app pool? So with .NET, you can go and configure your app pool to basically run on the .NET 4.6, or you can have it run on .NET Core 5. However, the other thing that you have an option for, and I'll show you in a second, is we have a brand new web server. It's a cross-platform web server. It's called Kestrel, that allows you to basically configure and run your application on any OS and also from any directory now. And I'll show you what that actually looks like. However, as I mentioned, you can now configure your application to run in either a .NET Core app pool or a ASP.NET, 4.6 app pool. So let's just look at some of the capabilities of ASP.NET 5 that are somewhat different than what you're perhaps used to. So the first thing I want to show you is the fact that I am sure you're all familiar and used to our beloved project file, which is basically a giant XML file. With ASP.NET 5, you no longer have essentially project files. And there's a very good reason for that. As we make the push to enable ASP.NET 5 not only on Windows but also OS X and Linux, we want to enable all developers, no matter what editor, no matter what IDE, no matter what they do, to be able to share the same code, same project across the various platforms. And so what we've done is we made an investment where we've taken a bet on the JSON format, where your dependencies are now nothing but essentially a number of statements in a JSON file. In fact, what you see on in the Solution Explorer is just a graphical representation of what you see in here. So let's pick an example. This ASP.NET authentication.cookies. What I can do here is notice as I delete this statement, that actually now also goes away. As I said, ASP.NET 5 is a modular framework that allows you to pretty much chop and change as you will. And now Visual Studio, rather than hard coding your references and dependencies, becomes nothing but a visual tool on top of your file. It's not going to dirty your file in any way, shape, or form anymore. In fact, as I just undo my edit, it just adds it back. So it's a much, much simpler model. The other one is you can now have basically, just like any other NuGet package. By the way, I should back up a little bit. I'm talking a lot about NuGet, NuGet, NuGet. NuGet is now our de facto way to distribute and also consume .NET libraries. It's essentially a packaging technology that's built by and also supported by our team. And the NuGet server is essentially hosted by us as well. And allows you to not only both upload as well as consume libraries from within Visual Studio, but also there's a command line tool that allows you to easily get NuGet packages as well. The question was, let's say you delete half of this file. How do you know which ones? Okay, the question was, let's say you delete half of this file. How do you know which ones you need back? You can actually right-click on your project and say manage your NuGet dependencies. And there's a restore command that basically looks at your what you're using and then restores your dependencies. So restore is a very useful feature in NuGet. And we have a session later on this week that goes into more detail as well. Let's just briefly look at something else, and that is my .root. I'm going to right-click and say open a folder. Let me just do this very quickly. Hopefully I didn't break anything. Oops, sorry. Let me just run the app. When I run the app, notice it comes up quite fast. And the reason why it comes up really fast is the fact that we are no longer compiling your C# code, saving the assemblies down to your disk, and loading it up back in the server. As I mentioned previously, we are using an in-memory compilation model that allows us to rapidly allow the developer to edit, compile, debug their application. In fact, if you look at the bin directory now that was generated, there is nothing in there. In the past, you'll see all these assemblies, all these DLLs, and now you see nothing because all the code is actually loaded up in memory. The other thing that I'd like to show you is let me just go and reset the window layout, is that if I were to basically make a change to the live application and simply go and change the About page, which right now it simply has a text of About, I can just say, hello, Ignite, save the file, I'm not going to compile anything, refresh my browser, and then once I've refreshed my browser, it will just show me the changes. So I no longer have to compile, and it's just there. Okay, so the question was around, you give up a lot by using the JSON format, and how do you handle things like web forms? Web form is an excellent question. So the thing I want to highlight the fact that ASP.NET 5, essentially right now the models that it support is Web API and also MVC. ASP.NET 5 does not support web forms. So if you're doing web forms development, now, some of you are extremely happy about that news because you're saying good riddance, web forms, that was 2001. And some of you are like, what? No web forms? And so let me go back. As I mentioned, one of the key philosophies around .NET Core and ASP.NET 5 is we want to bring developers and also the development model in the new era. And so when we looked at web forms, what we've found out is it was and still is an amazing technology for allowing rapid drag and drop development. But when you look at brand new workloads like the cloud workload today, it just does not scale and doesn't do well. So when we have customers either wanting to have hybrid scenarios or cloud-only scenarios, they move their web forms from on-prem to cloud, and suddenly their entire application breaks. So as I mentioned, with ASP.NET 5 and .NET Core, it was built for the cloud from the ground up so that you no longer suffer from those issues. Okay, let me briefly touch base on open source. Open source isn't just a fad for us. We live, we breathe, we sleep open source. When we first started down this journey, we thought about, what's it like to consume some of the open source offerings? And then later on, that went to, you know what? We should actually start behaving like the way that we want, essentially, the community to behave, which is we need to open source our own stack. So for us, open sourcing means that everything that we do in .NET Core, whether if it's ASP.NET 5, whether if it's C#6, whether if it's Roslyn, Analyzer, and so forth, it is all done in open source. It's a fully supported stack. I really want to make sure everyone hears that. I often get this look of, okay, so you're open sourcing it, does that mean you're not going to support it? Open source simply means where the source lives. It doesn't have anything to do with how we support it. So the stack that we produce on GitHub is completely supported and serviced by Microsoft, and that won't change. The other thing is the fact that, and this is a big, big change for us, in the past, open source at Microsoft meant one of two things. It's where projects go to die. And there have been several of those. The other thing is the fact that we've open sourced things, but we've actually just made source open, meaning we did not take back any contributions. With .NET Core, not only are we making the entire stack open source, but we're also taking back contributions. So anyone in this room, in fact, if you had an opportunity to go to GitHub, you would have noticed that there are a ton of pull requests that we've accepted so far. And also, we continue to see a lot of good engagement in the community. And anyone in this room can do exactly the same. I want to highlight, when we talk about open source, those rounded boxes are the things that we talk about. I want to make it clear, we have no intentions to open sourcing the full .NET framework. And the reason is there's an incredible amount of legacy as well as compatibility, and we want to honor and also be respectful to all the assets that customers have, and we don't want to go and willy-nilly change something. However, with .NET Core 5, it's a brand new stack, so from ground up and from day zero, we made the decision that the entire thing is open source. Why are we open sourcing .NET? Do we have some secret evil plan? The answer is no. But it's really about two things. We made the decision that we want to take .NET cross-plat. Guess what? It turns out that without an open source plan, you have no credibility when it comes to cross-plat. So if you want to go cross-plat, you need to be open source. The other thing that we found is there's an incredible set of smart engineers that don't work at Microsoft, and we love them to contribute to .NET. And so we made the decision that for both of those reasons, we want to make .NET open source. It turns out that .NET is the largest project at Microsoft ever to have been open sourced. And what's happened right now is a lot of teams at Microsoft are turning to our team and asking us for advice of how you go about open sourcing something as large as .NET. If any of you have ambitions or plans to take anything open source, we are going to do a how we open source .NET document in the future, so any of you in the room can basically see our trials and tribulations. When I say open source, it does not just mean source code. In fact, if you were to go to our GitHub page, you would have noticed we are now uploading videos from our design meetings. We are uploading our design guidelines. We are uploading everything that we do in .NET when it comes to .NET Core. So anyone now, in fact, in the future, I imagine talks like these won't be as interesting perhaps because everything would have already been in the open and you know exactly what would have happened. As I said, we do accept contributions. I do want to set the expectations though. Our bar is very high for taking on contributions. There are several reasons for that. .NET is used by millions of developers and hundreds of millions of consumers and enterprises. So we want to be very careful about what contributions we take. We have an entire team that looks at pedigree, looks at security, looks at everything that you can imagine to make sure that whatever contributions we take is of the highest quality. If you've been paying attention to things like GitHub, you would have noticed a tremendous amount of buzz around open source. And as a result, as I said, we are seeing hundreds and hundreds of developers right now to basically onboard .NET open source. The entire .NET open source framework, so to speak, is all housed within the .NET Foundation. The .NET Foundation is a really simple concept. We created the .NET Foundation to make sure that we have this vibrant and also vetted community where projects can live and prosper. In fact, if you go to the .NETFoundation.org or .NET.github.io, you will see essentially what is happening in the .NET Foundation as we speak. With .NET Foundation, we make sure that we provide protection, everything around copyrights, licensing, and it's not only projects from Microsoft, but also projects from around the world. Xamarin and others, for example, are contributing to it as we speak. Practices, things around governance and so forth. .NET Foundation essentially sets forth a number of practices, and then all projects within the foundation abide by those rules. Visibility will make sure that It doesn't matter what project it is, it gets lots of visibility. And then obviously, rapid innovation and openness are a core foundation of it. And as I said, Xamarin, Salesforce, and others are already part of the foundation. Okay. Now let's spend a little bit of time talking about the last part of the presentation, which is cross-platform. Cross-platform can actually mean one of two things. Cross-platform on the device and cross-platform on the server/cloud. I mentioned that we've partnered with Xamarin on the device side where you can use .NET in conjunction with Xamarin tools to create applications for Windows devices, iOS, and Android. On the server side, we've taken the approach of producing a version of .NET Core that basically runs on both OS X as well as Linux. So the diagram that you see on your left-hand side, the purple box, is the discussion that we're going to have in the next few minutes. So why would anyone care about having a .NET stack on OS X or Linux? .NET on Windows is an extremely thriving product right now, and it continues to do really well. And why should I care? First of all, let's start with the what. When I talk about .NET Core on Linux OS X, I specifically mean the area that I've highlighted. It means the set of capabilities that are shared between the various frameworks. It means .NET Core 5, and specifically it means ASP.NET 5. That's what makes up a .NET Core on Linux and OS X. It's basically all about the cloud/server workload. That is what .NET Core on Linux/OS X means. Now, why would you actually care about .NET on Linux? There are four main reasons why you want to care about .NET on Linux, depending on who you are. If you're a developer, what is happening is there are brand new workloads that either only exist on Linux or work better on Linux. A few examples that you've probably seen are Hadoop, Elasticsearch, and so forth. So what we've seen is customers are saying, I have this great .NET investment, but I want to be able to use Elasticsearch in my solution. How do I go about doing that? The next thing that we've seen is for businesses and organizations. We've seen brand new market opportunities where customers can now target their customers who only allow non-Windows deployments. That's actually turned out to be a really important business case for a number of our customers. And for CTOs, there are two key reasons why I care about .NET on Linux. The first one is, very obvious one, like any other portfolio, you want some diversification in your portfolio. So it allows you to take advantage of new capabilities that may only exist on Linux, and also depending on which way you want your company to go, you can essentially ramp up or down on either Windows or non-Windows OSs. And the second one is server consolidation. What we've seen is a number of CTOs are making decisions to move to the cloud, and when they do, they're consolidating on a single operating system. And sometimes that operating system happens to be a non-Windows operating system. So those are the four reasons why you care about that. As a developer, why do I care about it? And what are the benefits? So one of the promises that we are making is if you are to write your .NET Core application, you can run it on Windows, OS X, and Linux. And so if you have a server/cloud workload, you can just run the same application on Linux as well as Windows. We're going to provide first-class support in Visual Studio. That means editing, compiling, and remote debugging from Visual Studio to a Linux machine. And so that's going to be a huge capability where you as a developer are not going to take a productivity hit just because your deployment environment is now Linux. If you're on OS X, you can also now edit, compile, and debug using your favorite editor, be it Sublime Text, or the product that we just announced at Build last week, which is Visual Studio Code. And last but not least, the entire .NET Core is open source, so you can go and make any changes if you like to make it run better, let's say, on your Linux server or Linux appliance. The most important questions that I get when I talk about .NET on Linux is, what about all my data? Are you going to ask me to migrate my data to a database that runs on Linux? And the answer is absolutely no. If you're running your database on either SQL Server or SQL in Azure, you can simply run the same code without any changes on Linux. And so there's no data migration, there are no changes to your code. So we are starting with SQL Server and SQL Azure to begin with. However, we are strongly considering other providers also that allow you to then access those databases. Let me show you a really, really quick example. These fresh bits are extremely fresh, so excuse if the demo actually doesn't work, but let's go and try it out anyway. So here I have a Linux machine. It's actually Ubuntu 14.04. And the first thing you notice is I've got my shell. And what I've done before is I've downloaded Visual Studio Code. And the thing I love about Visual Studio Code, there is no installation. I just unzip the file. And I double click on it. And once I do, there it is. And guess what? Hell did not freeze over. If you told me 5 years ago that Microsoft was going to produce a cross-platform editor that runs on Linux, OS X, and Windows, I would have looked at you very funny. But those days are long gone. This is a brand new Microsoft. What you see there is a very simple, I'm sure everyone in this room has either used Northwind or AdventureWorks. It's a simple query to basically get a bunch of products out of AdventureWorks. Now, as I said, .NET Core and ASP.NET 5 are all Xcopy deployment. So what I'm going to do is I'm going to run this demo, and hopefully it'll work from the command line. And it's not a sexy demo, but ladies and gentlemen, this is a .NET application running on Linux talking to a SQL database in Azure. Let's see if it works. And there it is. So we have a bunch of products. Now, let that sink in for a second. We are talking about .NET running on Linux, talking to a SQL Server database. Our plan is we want to make the transition, if you happen to choose to, from your existing workloads to Linux seamless so that there should be as little rewrite/changes as possible. Okay. Let me briefly touch base. In case you are interested in what's happening with .NET on Linux, the experience right now is somewhat raw, but you have access to the bits as we speak. So if you are on Windows, you can, .NET Core actually comes with Visual Studio RC. What you can do is simply cross-deploy your application to Linux, and then it'll work. Or if you're brave enough, you can clone the entire .NET Core repo and build it locally on Windows if you like. If you're running on OS X, you can download and install essentially a tar file, which is a very popular packaging mechanism on both Linux and Unix. And you can just basically untar it to a local directory and go from there. Or for those of you who are using Homebrew, which is an extremely popular packaging mechanism or package manager on OS X, you can use Homebrew. On Linux, you can do pretty much the same thing. You'll also, if you want the most friction-free acquisition model, right now, you can go to Azure and then create an Azure VM that has the entire .NET Core stack on there. The other thing that I didn't touch base in, Visual Studio has full support for Docker now. Docker is a container technology. It's the world's most popular container technology. And so you can deploy your Linux applications via Docker. I'm just going to briefly leave that up there. We have a ton of resources for you to get started on .NET Core on Linux. But if I were just to highlight a couple, we have a bunch of tutorials that start from the hello world. And also, we have a sample application called Parts Unlimited that allows you to explore the entire .NET on Linux OS X in all its glory. We have a ton of different feedback channels. So
If you want to access us via email, blogs, anything that you might, I'm going to leave that slide up there. But my main call to action in the last 10 seconds is this. As I mentioned at the beginning, .NET 2015 is a huge release. I literally touched base on a few things, and there are so many other things in .NET 2015. I would highly encourage you to please go and download Visual Studio 2015 RC and really start to familiarize yourself with .NET 2015. And as I mentioned, if you do have any additional questions, there is my email address. With that, I'd like to thank you all and have a great rest of the day.